construction and infrastructure, there exists a pragmatic solution that challenges the conventional notion of demolishing and rebuilding. Retrofitting, an economically sound approach, extends the lifespan of existing structures, sparing them from the wrecking ball. At the end of this transformation lies fiber-reinforced polymer. Using FRP provides game-changing techniques and revolutionizes the reinforcements of concrete structures from the exterior. Being non-corrodible, lightweight, high tensile strength, and easy to being applied, FRP are competitive and sustainable material for structural strengthening on the domain of flexural strengthening, for reinforcing structure, for wide-stand bending force, shear strengthening, for enhancing structure to resist the shear force, column confinement and ductility improvement, for restraining column, for improved performance and ductility. This cinematic journey explores the world of FRP retrofitting, where engineering merges seamlessly with practicality and aging structures are given a new lease on life. Join us as we delve into the fascinating potential of FRP, witnessing the rebirth of a structure that defied the passage of time, standing stronger than ever. As we delve deeper into the world of FRP retrofitting, let's unveil the cutting-edge methods that are transforming reinforced concrete structures. FRP system for strengthening primarily employs two distinct approaches: the externally bonded reinforcement (EBR) and the near surface mounted techniques (NSM). These systems harness the exceptional potential of carbon fiber reinforced polymer or glass fiber reinforced polymer, reshaping the future of structural enhancement. Externally bonded reinforcement (EBR) method, which is the most common method for strengthening reinforced concrete structure, is based on applying fabrics in suit cutting system or laminates, pre-cured system, glued externally on the surface of element to strengthen. EBR can be applied using strips or continuous jacketing. Three main configurations of FRP strengthening may be used for externally bonded reinforcement, such as side binding, U-wrapping, and complete wrapping. The installation process of EBR is included of surface wrapping. Remove the coating of concrete surface, polishing the surface, cleaning, setting out, and apply primer adhesive into the surface of concrete. Fabric cutting. Cutting fiber reinforced fabrics or laminates into the size. Applying impregnation adhesive and then the fabrics or laminate, and finally leveling the surface from one end to the other. Pre-stressing is required. First, we should consider the position and the optimal placement of both the carbon fiber strip and the anchor devices. Next is the surface preparation and drilling holes from installation of the anchor devices, applying anchors and installing bonding box at both ends of structural elements. Next is fabric cutting, fixing the laminates, and fixing jacks and high-strength anchor bolts. Applying epoxy resin adhesive, pre-stressing the laminate, and removing the thread box, tablet fixing, and finally applying finishing product protection. Ready for some fun? How about we take a quick spin with a little test to relieve the magic of retrofitting? Get ready to watch the result unfolded through a company style. The companies compare the flexural behavior of two similar beams before and after strengthening. Amazing! That's a combined weight of 600 kilograms, so a concrete beam that couldn't even support one person can now support all these people, no problem, just by adding a single strip of FRP. Near surface mounted fiber reinforced polymer method for structural strengthening is based on the insertion of laminates or rods into the grooves open on the concrete cover or slit where the width is relatively small. This strengthening technique has attracted the attention of scientific committee due to its better bond performance, better protection of FRP material from adverse physical and/or environmental attacks, minimal changes on appearance of structural elements, and higher strengthening efficiency in both flexural and shear strengthening than EBR technique. Flexural and shear strengthening of reinforced concrete structural elements are two of the most prevalent applications of NSM FRP techniques. The installation process of NSM FRP is included of cutting the groove on the concrete surface, then cleaning the groove and applying adhesive into the groove to around half of the groove height, and inserting the FRP strip and bar into the groove, and finally filling the groove with adhesive. EBR and NSM system are both commonly utilized to reinforce the outer layer of concrete, often considered the weakest part of the structure. However, issues with premature system failure, particularly notable with EBR technique, have been a concern. Recently, a novel method known as mechanically fastened and externally bonded reinforcement emerged to tackle these challenges. The MF-EBR technique introduces multidirectional carbon fiber laminates that are affixed and anchored to the concrete simultaneously, aiming to address premature system failure. Notably, all anchors in this technique can be pre-stressed, enhancing the overall efficiency of the approach. In the next video, we will discuss in more detail the new method of strengthening, MF-EBR.